Hi there, so today we are going to start the new topic for higher chemistry, which is enthalpy. You will have looked at some of this stuff before in National 5 when you talked about enthalpy of combustion, and you will have also talked about enthalpy diagrams when we're doing rates, potential energy diagrams. We are going to start by basically going back over some National 5 stuff, and then we're going to basically use that into a higher level. So an enthalpy change, we're going to first look at how we would be able to find out an enthalpy change through experiments. But basically, in case you did not know this already, an enthalpy change is simply just a change in energy. And from National 5, we know that these can be either endothermic, which is when the chemical reaction gains energy, or exothermic, when the chemical reaction loses energy. The energy change for any reaction, and this was the equation used for National 5, is E equals C times M times delta T. On the next slide, I'm going to go over what each of these mean and some hints and tricks for using the equation. C is the specific heat capacity of water, which is 4.18 in chemistry, and what this means in simple terms is it's the amount of energy needed to raise 1 kilogram of water by 1 degree Celsius. But you don't need to know much more than that. All it's to do with is how much energy is needed to make it increase temperature. Mass is not the mass of whatever you're burning, how much has been used up. It is the mass of water being heated. Okay, so be very clear about this when we go through. We measure this in kilograms, so you sometimes have to change this into kilograms to be able to use it, and we'll be doing that when we go through our examples that are on the next few slides. Delta T is the change in temperature, and that's in degrees Celsius. So that's just basically you would take one temperature away from the other, and that would give you the change. Okay, but don't worry, we'll be practicing this anyway. You should be able to remember how to do this from National 5, but obviously that was last year. So it's maybe a wee bit rusty, but we'll be going over some examples, so don't worry. And I know that there are a few of you as well that are crashing, so don't worry about that. Okay, this was the experiment that you did in National 5. I'm going to put in a link to a video to show you how this happens. But basically, you can see this is the wee spirit burner here. That basically would go on, be set alight, the alcohol would be burned. And we measure the mass of the alcohol before we start burning and measure the mass of the alcohol after we start burning. That will heat the water, and the thermometer in there, I'm just going to get these up. The thermometer in there will obviously change temperature with the water because it's absorbing the heat from this burning. As you can see here, this insulation would kind of be done in a special box, and that basically stops heat loss going into the surroundings, and we're going to be talking about that quite a lot as we go through this topic. Basically that would affect your results because all the heat energy that you're burning is not going into the water, okay? But we'll talk about that more. One thing to note as well is you would use a copper can or a metal can because it's a good conductor of heat, and that would pass the energy into the water so you can get an accurate result. Remember, 1 centimetre cubed of water is the same as 1 gram, okay? So 1 centimetre cubed of water has a mass of 1 gram. If you had 100 centimetres cubed, that's also 100 grams, which turns into 0.1 kilograms, okay? So that's what we're going to be looking at as we go through. We need to change it into kilograms, okay? So basically, you divide, if it's in centimetres cubed, you divide it by 1,000. Okay, so here are some calculations that I would like you to try, okay? Now I'm going to go over 1 and 2 in the next slide to show you how to do it, if you can't do it already, because maybe National 5's a wee bit rusty, and that's okay. Feel free to pause at this point if you just want to try them yourself. What I will mention as well is that question 4 is quite tricky because you have to change the equation around, so just be wary of that. I am going to go over that at the end, so if you get stuck on that, don't worry too much. Okay, so I'm going to go over the first question, and I can zoom in here to basically make my writing neater. Okay, so we're going to be looking at calculating the energy needed to heat 100 centimetres cubed of water by 55 degrees Celsius, okay? And I've got my wee pencil here, and I'm just going to write it as if I was writing it up on the board. First of all, we'd write the equation, which is E equals Cm delta T, okay? Then we need to start putting in our information that we know. We know that the specific heat capacity, the C, is 4.18. And this will always be 4.18 as long as it's water. Sometimes they might give you a different thing that you're heating, like a different liquid in the can, but they would give you the specific heat capacity of that. They would give you the value for C. They have to. The mass is obviously 100 centimetres cubed of water, but we needed to do something to that first before we were able to use it in this equation, and that was change into kilograms. So 100 centimetres cubed of water is the same as 0.1 kilograms. So our M here would be 0.1. The change in temperature is 55 degrees Celsius because it's telling you that you're heating that by 55 degrees Celsius. That means our answer is going to be, if you would use the calculator, it'd be 22.99 kilojoules. And I'm going to introduce something to you just now. So if this is heating 100 centimetres cubed of water, then it's going to be exothermic because it is giving out heat and that is heating the water. That means that when the alcohol, or it doesn't actually say alcohol, it could be anything that you're burning actually, whenever that's been burned, that means it itself is losing heat energy. Although the water might be gaining heat energy, the thing that you're burning is losing that heat energy. So we are going to put a negative sign here to tell us that the chemical reaction is losing heat energy, okay? It's exothermic. And that is how we do our first question, okay? I'm going to try the next one now and let you see how that's done. Okay, so how much energy is needed to heat 500 grams of water from 18 degrees Celsius to 75 degrees Celsius, okay? So there's a few more steps in here, but it's just the same, just with a few extra things. So, as before, we'll do E equals Cm delta T. I told you that C would always be 4.18 if it's water we're heating, which it is in this case. Our M, well, we've got 500 grams here. Notice it's not in centimetres cubed, but you would still divide by 1,000 to get into kilograms, so that's going to be 0.5 kilograms. And our delta T is going to be the difference between 18 and 75. So you could do 75 to get 18, and that gives you a change in temperature of 57 degrees Celsius. When you put that into the calculator, you'll end up with a value of 119.13 kilojoules. And because it is heating the water, because you're burning something, then it's going to be negative because it's exothermic. That chemical that you're burning is going to be negative. There you go. And that is the answer for that one there. So I'll let you go back here. If you want to pause at this point and try any of these, that's fine. You can just pause the video. What I'm going to do is I'm going to go to the last one and I'm going to show you how I would do that one. Oh, here are actually the answers. But if you get stuck with the last one, here it is here. So what will the temperature change be if 250 grams of water is supplied with 104 kilojoules of heat energy? Okay, so let's try this one. E equals Cm delta T. However, what we are interested in this time is delta T and not the actual energy, because we've already got that. So what we need to do is we need to rearrange this equation. Okay, so what we can do is we can see that C and M could be brought down underneath the E, if you're familiar with this in maths. If that is not something that you like doing, I've got a wee trick as well. You could draw out the triangle, and you have E in the top, C, M, delta T. If we want to find out delta T, we can colour that in, and that shows you how we would set that equation up. So E is on top and C and M are below, so we're dividing by C and M. So that would be E over Cm is equal to delta T. I'm going to zoom out and zoom back in so I've got more space. Didn't even have to do that. What we're going to do now is we know that the energy is 104.5 kilojoules. We know that our C was always 4.18. And if we look at the question as well, it says that it's 250 grams of water. So if I change that into kilograms first, I'm going to be putting a wee 0.25 in here. That is equal to my delta T. So if I put that into the calculator, 104.5, and I'll simplify this. This is always a good step to do if you've not got one of the fancy calculators that does like the maths thing. Then what I would do is I would basically do this in as if it was a bracket and work out what this is first, and then that gives you a nice easy division to do. So 4.18 times 0.25 is actually 1.045. So that means 104.5 divided by 1.045 is actually 100. So our delta T is actually 100 degrees Celsius. So that was just a wee bit tricky because of the extra wee steps to change the way the equation is set out. And hopefully that makes sense. What to do is there is a questions sheet, and you should try and do the questions. Your teacher will also upload the answer sheet as well. But you'll do that first, and then when you're finished, your teacher will probably put that up at the end of the session. Now, thank you very much for listening. Hopefully this was helpful, and if you need any help, please do not hesitate to contact your teacher. Thank you.